Okay, so let's talk through the Hershey's Kisses. So we're going to say that instead of doing 50, we're going to do 100, 10 of them 10 times. And so we've tossed them and counted and tossed and counted, and we got out of that 100 drops that 37 of them landed flat. So that's 37 out of 100, or 0.37. So this is our p hat. Our p hat is 0.37. So let's look at what is our population. Well, our population are all Hershey's Kisses. All right, and so from that, our parameter, P equals the true proportion of that land flat. Okay, our sample is 100 Hershey's Kisses. Now we did 10 of them 10 times, so they all count the same. So N equals 100. And our statistic So we then look at our statistic. Since 37 of the 100 landed it flat, so that's p hat again equals 0.37. Was this a random sample? Yes, because we randomly selected from the bag ten Hershey's Kisses. And so this answer is yes. And why is that important? One, it helps us to generalize to the population. Excuse me. And two, it helps us to assume independence. Okay, what is the formula for calculating the standard deviation of a sampling distribution of p hat? If we look at our formula page, it's p times 1 minus p, which is q, over n. Okay, so if p is 0.37, then q hat is going to be 0.63. Okay, but we don't know necessarily. Sigma is the square root of p q over n. Now, we don't know p and q. Okay, we don't know p and q. Okay, what condition must be met for this formula to be used? And that's the 10% condition. That is the 10% condition. And has it been met? That answer is yes, because 100 is less than 10% of all Hershey's Kisses. Okay, our next question is, we don't know the value of p, so we'll use p hat instead to calculate the standard deviation. This is called the standard error. We use p hat. So we say that our standard error equals the square root p hat q hat over n. And so for my problem, I don't know what your numbers were up here, but mine is 0.37 times 0.63 divided by 100. And if we use our calculator on that, second square root 0.37 times 0.63 divided by 100, It's 0.048. 0.048. And it then asks, would it be appropriate to use a normal model? And the answer to that, since we do our success failures, NP and NQ, since NP was 100 times 0.37 or 37, and NQ is 100 times 0.63 or 63. And these are both greater than or equal to 10. So yes, it's both were greater than 10 successes and greater than 10 failures. Again, this is called success failure. Okay, so let's turn the page and look at this. Real quickly, in a normal distribution, we expect 2 standard deviations to have 95% of the data. Well, excuse me, since we're doing a normal model, we're going to find, we need to call what are called critical values, and those are Z stars. And to find Z stars, we can use the table or we can use the inverse norm, but I'm going to go ahead and just tell you those numbers. This is 1.282. This value is 1.645. These are important when finding the confidence interval. This is 1.96. And then for 99%, it's 2.576. So we're going to calculate the margin of error. Okay, the margin of error is determined by multiplying Z star, the critical value up here, times the standard error. Well, the standard error from up front, Z star for a 95% is 1.96, and our number up front was 0.048. And so then grab the handy dandy calculator again and go 1.96, which is our critical value, times 0.048, which is our standard error, and that's 0.094. So this, is 0.094. So to find the confidence interval, we use our point estimate, So our confidence interval is p hat, this is our main formula, plus or minus Z star, our margin of error here, times our standard error. And so that looks like 0.37 plus or minus 0.094. So we're going to go 0.094 plus 0.37, it's 0.464. And we're going to go 0.37 minus 0.094, and that's 0.276. So there would be our interval. And if we had a line drawn out from 0 to 1, and here's 0.5, and here's 0.25, I'm abbreviating this obviously, 0.75, so 2.76 would be right about here, and 464 would be right about here, and then we would draw a line connecting those two. And we did that, and we had a bunch of various values, a lot of intervals. And when we got through doing our intervals, I then showed you that the main value was 3.5, okay? And 3.5 is right about here. And we would expect about 95%, okay? P on this was 0.35. So we then look at the takeaways from this. One, you need to know the conditions, which you can go back and look at the conditions up front, which were random, the 10% condition. We want less than 10% of the population, and success failures. You want at least 10 successes and 10 failures. Okay. We also got from this we used our critical values, Z stars, critical values, and I'm not going to worry about 80% again, but 90% was 1.645. 95% is 1.96. We'll go ahead and throw a new one in there, 98%. Excuse me. Is 2.326. And 2.576 is 99%. Those are important when finding our margin of error. And again, you need to know to find your confidence interval, it's p hat plus or minus the the critical value times the standard error. And standard error is found by the square root I'm going to do that over here, sorry. Standard error equals the square root p hat q hat over n. I hope that helps. Now I'm going to pause the video. I'm going to create a new one for check your understanding.